We wanted to make 3D imaging as ubiquitous as its 2D counterparts, essentially, to create a chipset that would do for 3D imaging the same as the CMOS image sensor did for photography and video. Pointcloud designed silicon-based high-performance 3D imaging sensors. We wanted to enable a wide variety of applications, anywhere from mobile applications to autonomous mobility to drones to humanoid robots. In a nutshell, to enable physical AI. Our latest chips have achieved as many as 0.6 million components, photonic components per chip, and we actually have a design which is ready to go into manufacturing for over 1 million components per chip, and many millions of transistors. And all of this has been achieved with help from our partners, from our manufacturing partner as well as from our design partner, Cadence.
So I use Cadence mostly for designing photonics circuit, and Cadence made our life so much easier because we can take the components that the foundry gives us and allows us to combine them in all sorts of different things to realize our design, in the sense of creating pixels of a certain size, integrating components. You can think of a pixel as in the same sense of the single pixel that you have in a CMOS camera, for example. It's the smallest unit that constitutes your camera and corresponds, in our case, to a single point then in the image that we are going to reconstruct.
For design, we use Cadence Virtuoso Studio Photonics platform. For simulations, we use Spectre. As far as manufacturing, we use the Photonics platform from Global Foundries.
In my everyday, I use Cadence Virtuoso Studio for photonics layouting, and in particular its ability to be scripted through scale, because it allows us to place the several hundred thousands components that we need for our design much faster, and allows us to scale the design in a much easier and uncomplicated way. And in particular, also through the scripting, we can use Curvy Core to really tailor the single optical components that can be designed really to our needs. Besides that, I also use Pegasus for DRC and LDS, because it allows us to basically match the photonic layouting to the electronic one. It allows us to also integrate in a much easier way the electronic components of our design.
We saw a unique opportunity. We thought Silicon Photonics was uniquely positioned to integrate all this complexity into a single chip, and by doing this, driving the performance up while reducing the cost dramatically.